But give me meters. I don't really know how long now.
Hello guys, we are back with another video. If you are new to the channel, please subscribe our channel and also press the bell icon to remain updated. Also like our video. Follow us on TikTok and Instagram. The handle is Dr. Buzz Lecture. So let's move on to the today's topic, which is fatty acid synthesis. So as we know that there is three macromolecules, carbohydrate, protein and lipid is the third macromolecule. Lipid is mainly present in red meat, milk, butter, etc. So, as we know that lipid is mainly stored in body in the form of triacylglyceride, which is formed by three fatty acids and one glycerol. So every three acid and one glycerol makes one triacylglyceride. So fatty acid and glycerol are the forms of lipid. So now when we eat something, let's say that we ate a burger today. Tasty. So, when we'll eat a burger, the glucose level in the body will get high. So, to reduce it, insulin will be released from pancreas to reduce glucose level. So, what reactions happens in the body? It is basically a recall of previous lectures how the reaction happens when glucose is more in the body. So when there will be more glucose in the body, first process which will happen is glycolysis, which will convert glucose into pyruvate in cytoplasm, two molecules of it. Then pyruvate will go into the mitochondria and convert into acetyl CoA with pyruvate dehydrogenase. So acetyl CoA will add up with oxaloacetate and convert itself into citrate, which is Krebs cycle. During Krebs cycle, we get NADH and FADH2 molecules. So these are very important. The third process which happens is electron transport chain. In electron transport chain, NADH and FADH2 releases ATP. So these three process happens, then we get more ATP. When there will be more ATP, it will cause some enzymes to slow down and it will stop their function. So when there will be no process left to happen, then there will be fatty acid synthesis. So we can store it in the form of fatty acid. So there are some short and medium fatty acid and long fatty acids. Short and medium we get from our diet, and long fatty acid we get from liver cell, in which different fatty acid arrange itself in a way to create a long fatty acid like acetyl CoA converts into palmitoyl, which is 16 carbon fatty acid. Mainly in this reaction we use energy molecule NADPH, which we get from pentose phosphate pathway. So let's start how the process of fatty acid synthesis happens. First of all, we will get that acetyl CoA is in mitochondria, but it cannot come into cytoplasm. So it will add up with oxaloacetate and convert into citrate. Now citrate can come out of the mitochondria to cytoplasm. Then citrate will convert again into acetyl-CoA and oxaloacetate. Now here is another problem. Oxaloacetate want to get in, but it cannot. So oxaloacetate will do what? It will convert itself into pyruvate by the enzyme called malic enzyme, in which one NADP plus will be changed into one ADPH. We get one energy molecule, and pyruvate can be sent to mitochondria again. With the help of enzyme pyruvate carboxylase, it can again convert it into oxaloacetate. So now what happens in is acetyl CoA will convert it into malonyl CoA, which is a regulate which will help us in building fatty acids. So it will convert into malonyl CoA by the enzyme called acetyl CoA carboxylase with the help of cofactors, hydrocarbonate, bicarbonate, and ATP, biotin, and carbon dioxide. So now we will discuss how acetyl CoA is regulated. First thing is hormone. Which hormone increases or decreases its regulation? Glucagon inhibits acetyl CoA regulation or conversion to malonyl CoA. and insulin increases or stimulates. The second thing which regulates is allostatic way, and in allostatic we have citrate and fatty acid. Citrate stimulates you because more citrate will increase the production of acetyl CoA to malonyl, but more fatty acid production will cause inhibition of this reaction. So now let's go on to the main business. So you can see one molecule which has one cis part and one ACP part. Cis means cysteine and ACP means acetyl carrier protein. So it is basically a fatty acid carrier complex in which first we will add acetyl CoA with the release of CoA and enzyme transacylase. Transacylase will add up two molecules of acetyl or carbon in the ACP part. Now in the second reaction what happens is two carbon from ACP will get transferred to the cysteine part by the help of enzyme called acetyl transacylase. Again same enzyme. In third reaction, as we know that the two carbon are on cysteine, the malonyl CoA will come in and release CoA and adds up into the ACP with the help of enzyme malonyl transacylase. So the enzymes are same till now. What happens in the fourth reaction, which is a different, in which carbon dioxide is released because one carbon is lost. So what happens is from two carbon of acetyl, one carbon will shift to the malonyl by the enzyme acyl malonyl condensing enzyme to convert into beta ketone. In these 5 to 8 reactions they are same, 5 to 7 are same, but only there are and there will be some release of some molecules. In fifth, beta ketone will be converted into 3 hydroxy si, in which NADPH will be used to release NADP plus by the enzyme called beta ketoacyl reductase. In sixth, we will release H2O water, in which there will be enzyme 3-hydroxyacyl dehydratase, and in it we will get anoyl ACP. So let's discuss again. From fifth, beta ketone will be converted into 3-hydroxyacyl, and then sixth to seventh, 3-hydroxyacyl will be converted into anoyl. As you can see, the shift or movement of the carbon is not happening because there is no movement, only there will be some reactions to release some molecules. So in seventh, anoyl ACP reductase will release NADPH to NADP plus. In eighth one, which is an important one, that there will be movement of position of 4 carbons to the cis part by the enzyme called acyl transacylase. Now we have 4 carbons. So now again malonyl will come to the 3 carbon to ACP part, and again 1 carbon will be lost in next process in the form of carbon dioxide, and we will get 3 carbon, and we will add up with it, and with the enzyme acyl malonyl condensing enzyme we get 6 carbons. So it is a short process in which we get extra 2 carbons. So what happens here is I again tell you in a simple way that beta ketone will be converted into 3-hydroxyacyl, and then 3-hydroxyacyl will again be converted into uh, anoyl ACP. So by this we get 2 carbons by each process. So here we get 4 carbons and 2 carbon, so 2 extra carbons. So to get 16 we will do this 6 times. We have done this one time, but we will do it 5 more time to get 16 carbon fatty acid. So this was today's topic. I know this is difficult little a bit. I will suggest to watch again and take a material with it, so you will understand it in a right way. So thanks for watching the video. Hope you have liked it. I will suggest you to watch it again if you have any queries. I will come again to you with a new video. Till
Forgive me,
then,
readers.
bye
I don't
bye
really know how
guys.
long.